clarity to the satellite image. So likewise, we can also give the code like stretch is equal to hist, that is histogram. So this is the image. So after giving the histogram equalization, it looks like
Stretching.
this. And stage is equal to null. So null generally give the low brightness. So what happened to the image? So suppose there is the value of 84 to a 153, then it is stretched from 0 to 255, so that it give the more brightness to the image. So we just try this coding. So this is the linear stretching, LIN. So suppose this is the layer stacking of all the four bands of the LIS4 satellite image. Then after composite it, just giving the result. So this is the resultant of contrast stretch. So if you change to the histogram equalization, then it gives the different visualization. So this is the histogram equalization, that is hist. So this is the different. So in the histogram equalization stretching, the satellite image look like this. So it gives some more uh, brightness to the images, and also give the color some good color of the vegetation areas. And suppose for null, so this is the image in, if there is no stretching to the satellite image, so its features are not clearly visible in this in this system, in this method. And in linear stretching or histogram stretching, we can get the good visualization of that, good clarity of the image. Okay. Okay, Abhimanyu, you were asking on this yesterday for this also, na?
Thank you very much, sir. Really appreciate that you also took the time to explain. Thank you very much.
Okay, okay. So after that also a lot of histogram equalizations are there. You can use it. So now just see that. So for the supervised classifications or unsupervised classifications, so I have a image of Bhitarkanika National Park, which is situated in Odisha. So there is a mangrove forest. So these are the mangrove. This is the red color areas are mangroves, and this is the river. These are the mangroves, and this is the creek. So it is not the river or any drainage pattern. So creek is the opposite to the river, because generally the drainage system flowing from higher altitude to lower altitude, but creek, due to the tidal influence, it is coming from the lower altitude to higher altitudes. So It's a small part of this Bhitarkanika landscape. So this is the Bhitarkanika area, and this is the part. This part, this area is my study area. So how to classify in supervised and unsupervised classification? We will see after completing some theory class. So I just give you some information about some land use land cover. So generally this is the creek area. So this is the creek. So it is a tidal influence water bodies and not from the river part. So this is the creek. This is the mangrove forest of the Bhitarkanika National Park, and this area are the mangrove forest. So in our image, it is a false color satellite image, and it is due to the infrared bands. The mangrove reflects more. That's why it is easily distinguished. So in this area, there are lot of aquaculture ponds. So basically, it is culturing different prawn culture and some uh, uh, fishing activities and fishing ponds are there. So it these are look like same as the natural one. Okay, tell me. Okay, tell me what happened. Okay. So these are the aquaculture ponds. So sometimes during our supervised classification, the aquaculture ponds and pond near the village areas have the equal signature, so that sometimes it is difficult to identify the features. So I have decided, mm, I have just take this area and just divided into 6 classes. I just digitize and draw the points. Then taking the some of the sample of different mangrove areas and some agricultural lands, settlement, aquaculture, mud flat. So there are 6 classes are there. So maybe it is 8 or 9 classes, but basically the major classes are in this the mangrove forest, water bodies like creek, river, and then pond, and then agricultural land and settlements like the village settlements and some the hamlet settlements and aquacultures. So as it is a coastal area, so a lot of aquaculture practices are found. Basically in Odisha, a lot of aquacultures are found. So these are my sample area. So this is my train data. So it is not useful for the unsupervised classification. During our supervised classification, we use this train data and give this train data to the system. Then after that, it will classify it according to our train data. So before going to that, we will first discuss the today's topic. Then after that, we will go to the practical. So today,
Sir, I just sorry
there is
to
a topic.
interrupt. Just a small question.
Okay, tell me.
In the first semester, we saw there is one plugin called for semi-automatic classification. What is the difference between that and supervised learning?
Semi-automatic.
Classification?
Which technique?
I think there was
Semi-automatic means
SCE, I think, or something like that. There was SCP or
Sir,
I think yeah,
it was a plugin in QGIS, CSP,
okay.
semi-automatic classification.
Okay, there
Yeah,
is
so
a
I'm just
plugging, but
trying to
their
understand
work.
what is the difference. What is
Actually,
the difference between
this
that technique and supervised?
so this plugging may be using this supervised classification technique. So it is a custom based. There is a just a tool to classify this image, but mathematically or any algorithmically, this can use this type of any method, either random forest or SBM method or maximum likelihood methods. So method is same, but you can classify all these images in GeoJS or ArcGIS or R or Python, any software or any programming, but mathematical and logical analysis is the same thing. So there, I think in this plugin there is a hidden mathematical algorithm is there. So if you go to the Google, then they will explain which type of method is used. But
Thank you.
basically, without this, there is no other method is there. So you also know that in the data science or any AI and machine learning, these methods are also used. So we use in remote sensing unit as minimum unit as a pixel. Edge pixel has a lot of variance. So in the data science or machine learning, they use the consumer data or any related different data and population behavior, marketing data. So these data are analyzed. So the data is for remote sensing is pixel, and for other IT sector or other data science in the data science fields, they use some socio-economic datas and population data or different business analysis related data. Process is same, but data is different. Okay.
Thank you.
Okay. So just tell me which plugin is there. So I will just search and just explore what is the actual method is used. Semi-automatic
I think it was a
classification.
semi-automated classification.
Okay, okay. I just explore it, then I will tell you. So this is the classification, and so today there is a topic that is from MGY-06. So this is not my topic, so it is from Rakesh Thakur. So due to some medical issue, so I have to cover it. So today there is a spatial analysis and modeling. So spatial analysis in GIS means examining the location. So spatial means space-based information. So the location attributes means the different information related to the location. Then the relationship of features in spatial data through overlays like buffering or distance calculation, then queries and operations. So basically, spatial analysis related to the how some one area is related to the other area. What is the distance? What is the directions? So in the Google Map, we just use the map for the different locations. So in between, there is a special analysis are going on randomly, and that's why it give the outputs. So then special modeling, what is the special modeling? So it goes as a step further, and it was special data, rules, and mathematical statistical model to stimulate, predict, and explain special phenomena. So it is basically building a model of reality in GIS to understand the process of forecast outcomes. So in spatial modeling, like a lot of modeling techniques are there. So in this is a DSS model that is used for digital shoreline analysis. This is used for the mm, shoreline change detections and shoreline forecast. So how what is the trend of the shoreline change? What is the erosion area? What is the accretion area? And after 30 or 40 years, what is the train for particular areas. So this is the model, and this is the regressional model I used for this analysis. And then urban sprawling. So if you take some from 1990 to 2025 data in 10 years interval, then after analysis of land use land cover classification, then it give the forecast of the trend of the uh, land use land cover and urban sprawl, urban growth prediction also. It also calculate. So a lot of models are also there. There are a lot of plugin are also there in QGIS, and it is also used in the Python script. Likewise, in the field of atmospheric science and agriculture, then forestry, a lot of models are used for the estimation of different parameters. So this is the spatial modeling, and the spatial analysis is related to the direction, location, and latitude, longitude informations, area calculations, length. So basically, geometrical calculations and location directions are basically used in the spatial analysis. So spatial analysis and modeling are very much useful for research publications. So these two are very much integrated and give the good output. Then some purpose for spatial analysis is exploring, measuring. In the Google Earth image also we can measure, then describe spatial relationships. And in the spatial modeling, it's predict the future growth or future estimations, then stimulate and prescribe some outcomes. And then in spatial analysis, some approach is like query based approach. In RGS and other softwares are also there. So in RGS there is a query based approach is there in query builder. So this is the select by attribute. This is the query builder. We can use suppose class equal to aquaculture. So there is selected only aquaculture data in our system. So this is the selected data of aquaculture only. So you can see this in our database. There is the attribute. So only aquaculture data is uh, highlighted. So likewise, so we can use the normalization. Suppose how many data are there, which area is less than 10 hectare or greater than 10 hectare. So likewise, we can calculate different data by using query builder. So this is the thing about the query and statistics. Then spatial modeling, there is a mathematical statistical models with GIS like NDVI calculation, then NDBI calculation, brain ratio techniques. So a lot of things are there. Then spatial analysis giving the output like maps, patterns, relationships. And in spatial modeling, it is a scenario or forecast and simulations. Some example of the spatial analysis is like find all villages within 5 kilometers of river. So if there is a particular point, then we just buffering out. Then after that, we just select all these villages within the buffer of 5 kilometers or 10 kilometers. So this is useful for different plot based analysis and some health GIS also it is used. Mostly in health GIS, the buffer based analysis are used, how the disease is spreading, how this disease affected to particular area or due to some waterborne disease or airborne disease is there. So health GIS nowadays you very much you use this uh, buffer and overlay analysis. So out of this also a lot of analysis are there. Then spatial modeling that it predict how village may expand in 2035. So it is based on the sprawling or growth of the development of the village due to different factors. So which factor, suppose there is a growth of the particular directions in the urban areas, so what is the parameter or what is the constituent is present due to which the growth is particular in unidirectional, like the presence of the health facilities or hospitals and presence of the educational institutes are there, then the growth is towards this direction is uh, rapidly growing. So likewise, we can predict. So if some of the construction are going for different projects, then that may be the possible to growth in other direction also. This is then this type of predictions are can be possible with different models. So models basically used for the different applications like urban areas, agriculture, and other soil estimations, all these areas. Then integration of RS and GI. So remote sensing technique is generally use create some images of different theme or for different applications for like for earthquake and flood analysis. Microwave remote sensing is very much useful, and for urban area classification we use high resolution satellite like worldview 1, worldview 2, worldview 3, which have 0.45 to zero point 0.5 meter resolution, like 50 centimeter resolution. So it is very high resolution satellite image. That's why it is useful for the urban mapping. Likewise, cartosat image of the ISRO, it is also very much useful. It is also the resolution is 1 meter. 1 meter spatial resolution means the pixel is 1 meter into 1 meter, so that it is clearly visible all these features. So likewise, the different type of applications are different type of application have different type of satellites images, and for watershed mapping, the dam images there. So that's why these are the basic image. We can create some image based analysis, but after that we use the GIS platform for further enhancing our uh, outputs and give the multiple outputs or giving a particular user based results. So integration of remote sensing and GIS is very much important. So without this integration, there is not a good result can be found. So in this remote sensing, the raster and vector based integrations. So mostly the remote sensing data are in the raster form, and most of the GIS data are in the vector form. So we can convert the vector form data into raster form and the raster form data into vector form. So and the integration also used for this. So now we just see that so this is our raster image of satellite image. So we just use the shape file of point or polygon file, which is a GIS uh, file. So these are integratedly used for giving the output of the supervised classification of different methodology. So this is the when the GIS is concerned, then remote sensing data is very much helpful, and this is the foundation for the GIS work. So then integration of remote sensing and GIS is raster and vector data integration, then data mining and spatial database management, then overview of the geostatistics and spatial data management. So these are the ingredient for the integration of remote sensing and GIS. So first we just looked at integration of remote sensing and GIS. So in this Some remote sensing technology like providing raw data capture from satellites, aerial photographs, UAVs, and other sensors are there like thermal sensors are there. It supplies the so this satellite image supplies the multispectral data, hyperspectral data, thermal data, radar data. Already we have discussed this. Then it is useful for large area coverage and temporal monitoring, identifying physical, biophysical characteristics. Then some geographic information system that is act as a platform for storing, processing, analyzing, visualizing all these data. So this is the integration with other special database like cadastral maps, which are used as uh, a revenue map in 1 is to 4,000 scales. Then survey data, socioeconomic data, GPS data, and some ground truthing data. So these are associated with the GIS field, and it supports spatial modeling, decision making, and thematic mapping. So integration process, how this integration process is used. So data first we have to uh, data acquisitions. So we have to create some satellite image and drone image as a base. So on the base we can create other features. Then pre-processing like geometric corrections, radiometric correction, image enhancements. We also in the previous class we just saw that the image enhancements is very much useful for satellite image analysis. Then data import to GIS. So how we import in GIS platform or in any programming, also we have to import these softwares. Sorry, software. It is satellites. Then data fusion. So fusion means suppose we just already give the example like the integration of composite image like blue, green, red, infrared. We just fuse together and composite into image. And also it is possible that suppose there is a high resolution panchromatic satellite image that is 1 meter resolution, and we have some 5 meter resolution multispectral image. So if you want to convert this panchromatic, that means it is a black and white image, black and white image to color image. Then we just take the color code from the multispectral image. Then it transport to the black and white image. Then it is created the multispectral image in the panchromatic satellites. So that is the data fusions. So we can change the black and white satellite image like Cartosat. Sometimes we have to fusion with list for satellite image to give the better vision and better visualization of the objects. So this is the data fusion. Then analysis and modeling. If it is time permits, then we will show some practical of the data fusion. Some we have to I have to just explore some download some data fusion analysis, and then analysis and modeling, special analysis, change detection, suitability analysis, risk assessments. All these are analysis and modeling. Then output and decision making, map, report, web based GIS dashboards. So this is the hierarchy of the different satellite data acquisition, like from sensor development, then data collection, data processing, then some spectral analysis are there like hyperspectral analysis and other spectral analysis, reflectance measurement, thermal analysis, SAR, that is synthetic aperture radar analysis. So all these are remote sensing based analysis, which is called as spectral analysis. And then geospatial analysis like GIS integration, GIS data model, then machine learning models, predictive integrations, data fusions, then soil properties estimations. Suppose there is a soil properties, we have to estimate the soil properties. So some of the properties like soil texture, soil moisture, soil chemistry, soil organic matter, and soil erosion. So a lot of satellite images are there. So they give the different characteristic of the soil with the help of their image spectral bands. Then soil information and soil mapping also there. So soil property maps, land use, land cover maps, terrain topography. Then decision support. After getting the information of the different parameter of the soils, then some agriculture planning, environmental management, land use optimization can be done. And in the resource reporting, there is a policy recommendation, academic publications are also there. So in the different soil institutes and soil research institutes, and in agriculture research institute like National Rice Research Institute, they have some of the remote sensing like hyperspectral analysis are going on for the crop estimations, crop developments, and crop uh, canopy analysis. Then data mining in special database. So in data mining, generally it is discovering the useful patterns, trend, relationship from different data sets. When applied to special database, it is called as special data mining. So data mining means it is visualize some data, then statistics, then other disciplines and information science and database technology. So a lot of patterns, trend, and relationships are used from the database. Then that is called as data mining. So some of the tasks in special data mining are like classification. So classification means some assigning label to special objects. So suppose there is a satellite image of a forest or nearby forest areas. So if we classify it as a some of the part is forest, agriculture, urban areas, water bodies, based on the remote sensing and GIS technology. So this is the classification is one of the parameter. Then clustering, it is one of the parameter of the data mining. So in the clustering, it is grouping similar spatial objects. So in our supervised classifications of different methods are there. So basically they are using the clustering technology to create some different classes with the help of some pixel reflectance. So this is the clustering technology. Some of the example is identifying disease outbreak cluster in a city. Then associate rules like finding co-occurrence patterns, like some example is flood prone area often overlap with low lying paddy fields. So just if we have a satellite image and elevation informations, then we can easily predict which area will be affected more to the flood if the flood is happening due to the elevation informations and some association of the land use pattern. So this area can be categorized as the high vulnerable areas, and near to this is categorized as a moderate. Then some different classification of the land part can be done with the help of the elevations and the presence of the land use pattern in the buffering area of the river. Then trend detection identifying the spatial temporal changes. So monitoring shoreline change uh, from different years, or monitoring the urban growth, or monitoring of the soil health assessments. Then outlier detection, finding the anomalies like detecting illegal mining sites within a forest region. So basically, in the temporal region, if we take the different time satellite image, then we can get the accurate estimation of the illegal of the mining if we have the uh, original boundary of the mining areas, and if the outside of the mining area is some excavation is there, then we can find out with the help of this satellite image. Then integration of SDBMS and data mining, that is special database management system, handle storage, index, and special queries. So for all these operations and all this data handle query and all, there is a need of the database. So large database is needed. So based on this database, we can use all this information, just like the Google Earth engine. This is using the cloud database. So all this data are uh, stored in the cloud. So from this cloud data, we just extract the data, then use for different analysis. So database management is very much important for the remote for the GIS analysis. And data mining extract hidden pattern and knowledge of that data. So together they support decision support system of environment, urban growth, agriculture, health, disaster management. Also nowadays, largely using the remote sensing and GIS based data for different applications. So this is the uh, thing about the data mining and
So is
SDBM.
Geo database also?
Then benefit of RSGS
So is
integration. Yes, yes.
Geo
Geodatabase
Geo
is generally it is yes. So geodatabase is basically geodatabase is basically the database of the geological features, and it is storing all the related the satellite image, different vector images. So in a particular one folder, so all these operations can be used. So we just see how to create a geodatabase. Just give you some example. Suppose I want to create a geodatabase folder in ArcGIS software. Then just right click new. Then there is a file geodatabase and personal geodatabase. So file geodatabase has the larger memory, personal geodatabase has a smaller memory. So file geodatabase it create. Then after that we can import lot of features like shape file, other KML file, all other files can be stored in this database. And also it is possible to import all the satellite image, topographic image, all the geographic GIS based information data can be stored in a particular one areas. So this is called the geodatabase. So geodatabase features are nowadays used in different softwares. So in ArcGIS, it is basically a lot of time it is used. So this cannot be used in suppose it cannot be used in other softwares. So for particular software, that geodatabase can be open only in that softwares. But for using for other platform, we can export it into SAP file or other files. Then benefit is provide both spatial and temporal informations. Temporal means time-based informations. Then it enhance accuracy of land use, land cover mapping, resource management, and urban planning. Then allow real-time monitoring on environment, agriculture, water resource, and all related fields. So generally, RS provides, that is RS means the remote sensing provides what is happening through the image. So what is the current pattern of the image? What is the presence situation in the satellite image? It shows in the remote sensing data, while GIS provides where and why it is happening. So these questions are answered to this GIS through spatial analysis. So suppose there is a uh, flood area, and suppose in there is a flood is happening in the lower areas of the coastal areas, and large water bodies are covering the area from 10 or 20 meter sorry 200 meter buffer of the rivers. So it is showing in the satellite image like in the microwave satellite image. But in GIS we just find out how much area is covering, how it is affected. So why it is affected in particular area, So because it is a non-vegetation areas, or the elevation is very low elevation is present in that areas, and some sedimentation is very high in that areas. So lot of parameters are there. So this can be found with the help of GIS, and some predictive analysis can also be possible. So they form a powerful tool for research, planning, and management. So both the remote sensing and GIS are together we can use for different fields. So special database, that is already covered. Then store, manage special data. Then store point, line, polygon, and raster data, and support special queries like find all schools and within 2 kilometers of highway, list village inside flood affected zones, and manage both attribute like non-special name, population category. An example of some of the softwares like PostGIS, PostSQL, Oracle Special, ArcSD, MongoDB also know nowadays very much famous for the operations with special extensions are there. So these are nowadays used in the web different IT sectors. Then importance in GIS, that is provide efficient storage, retrieval, updating of large special database. Then ensure data integrity like topology. So if some point line polygon have some errors, then topology just correct this and just give the correct in data. Then enable multi-user access for large project, urban planning, disaster management. Then GIS integration. So different parameters are there for integration of the GIS. Like GPS is one of them. So generally GPS, that is global positioning system, provides accurate location of latitude, longitude, altitude using satellite. And in GIS, GPS collect field data such as road, land parcel, and area of different areas. And integration with GIS allow real-time mapping, navigations, asset tracking, and correction of the some classifications of different features. So basically, GPS is for the positioning of that particular areas. Then Internet GIS, that refers to the use of GIS application over the internet. A user can view, analyze, and share spatial data through web browser without installing heavy desktop software, and enable wider accessibility for government agencies, research, and publications. So nowadays, just like the Google Earth, so you can explore all these areas of the world within a second. So this is the very high resolution satellite image. That is, I think, 15 centimeter resolution in this satellite image is there. So all this satellite image we can visualize all over the world, so very easily in any system. But actually, if we get the satellite image of particular small areas in our system, then it may be the memory of more than 100 or 200 GB, as it is a very high resolution satellite. So it's very much difficult to just visualize and zoom in, zoom out all these images. But due to the some Google Earth and other web-based apps are there, we can visualize all over the world and give location informations related to this. And this is a wider accessibility and government agencies, research, and public and personal use also. It is very much helpful. Then Internet Map Server. So IMS system, so that host special data maps like ISRI ArcGIS server is there, Geo server is there, Map server is there. Then wireless technology like Wi-Fi, cellular, satellite communications. So all are parameter of this. And the WebGIS, that standardized online service that allows specific applications to exchange special data. So generally, a lot of applications are there, and there is a database central database. So from this database we can use all this data for our different purpose, and we can query, we can analyze, we can map, and we can measure the distance from of one point to other another points, and can we can access the satellite image with the help of these web-based platforms very easily and free of cost also. We can analyze all these things. This is the thing about the WebGIS. Then geostatistics. So when the statistical analysis is based on the surface of Earth, or uh, some related to the Earth surface, then this technology, this methodology is called the geostatistics. So basically, most of the time, the socio-economic statistics are there. But in our remote sensing GIS platform, if you give the information about a particular special data and give the different statistics, then it is a geostatistical analysis. So it's a branch of statistics dealing with the special correlated data, unlike traditional statistics. And various components are there of the geostatistics, like exploratory special data analysis, that is examine pattern, cluster, outlier in special data, mapping disease spread in city. So one of the example. Then special auto correlations, like measure whether nearby location have similar values or not. Then area close to each other tend to have similar rainfall. So it can be also found what is the relationship between the different locations and the rainfall or temperatures or humidities. Then variogram analysis, like the function that shows how special correlation decreases with distance. So if there is a distance in different features, so there is a change in the different pattern, like when there is a distance from the sea of the particular location, then change in the temperature difference is also found, and when the distance from forest area also, there is a change in the temperature and rainfall also found. So these are the some variogram analysis, and importance for predicting values in unsampled areas. The interpolations, the like the prediction is like method is Kriging, IDW, that is inverse distance weighting, spleen estimation, that unsampled locations, and predicting soil nutrient in area without sample. So a lot of applications are there, interpolations are there, and modeling and simulations using risk assessment, resource estimation, mining, groundwater, environment, and climatic factors analysis. Then overview of the geostatistics, like spatial data measurement, point data, that is rainfall at weather stations, groundwater level. So we just store all this rainfall data in the way of Excel data in general form, and another way is in the GIS form, that is the point data in the shapefile form. We can use this shapefile informations for different locations. Then groundwater data also stored in the GIS form, like the point data, and in the form of the different whale, or a lot of uh, points can be found. Then soil samples also found in, basically soil samples can be found in point or polygon data. And continuous spatial data field, that is very much smooth across space, temperature distribution, elevations, pollution concentrations. So these are all related uh, methodologies they are used in different applications. So nowadays geostatistical analysis is very much useful in different fields, like in meteorological institute, and then groundwater, geology, agriculture, forestry, and health sectors also using this data. So now geostatistics is now application is now increases very largely. So the some of the application is in the environment science, like polluting mapping, pollution mapping, soil fertility, climate modeling, hydrology like rainfall modeling, groundwater potential mapping, mining and natural resource, ore body estimation, oil explorations, public health like disease hotspot mapping, agriculture like precision farming, yield estimations, and also sometimes it is used as a greenhouse gas estimations of particular areas as most of the crop like paddy field uh, have some a lot of greenhouse gas emission is found, so this can be estimated with the field data integration. This is one of the agriculture applications how they are using the geostatistics using various parameters are there with the different distance, latitude, longitude information, and different samples are collected and giving the different graphs and different images. And this is also one of the other applications
Sir,
like for
in the
temperature.
previous slide, yeah, you said latitude, longitude information is used, but here I see only horizontal distance.
Latitude, longitude, horizontal distance in centimeter. Latitude, longitude is not seen here. It is not latitude, longitude. It's a distance in cm. Soil depth and distance in cm. These are other values are there.
Okay, this is depth, horizontal. So depth versus horizontal distance, like this is like kind of a agricultural scene.
Yes, this is a agriculture related precision agriculture map of soil available water, how the water is available is. So when they give some sample in point data of different areas, so what is the availability of water? So based on this, what is the growth of the plants and how they are using the growth estimations are calculated. So this way, this is like all other applications are there for different groundwater estimations and thermal changes of different locations. So different contour maps are created based on the elevations, based on the temperature, based on the rainfalls. So all these can be used with the help of some atmospheric data. So you can create different overlay analysis and some buffering analysis using all these data. This is about all geostatistics. So now we will check one of our practical section of supervised and unsupervised classification, which is left. So we have to just execute all these libraries.
सर एक क्वेश्चन था मेरा.
हाँ बोलिए.
सर जैसे हम मतलब जो सैटेलाइट जो होता है उसका हर सैटेलाइट का एक पर्टिकुलर रिविजिट टाइम होता है और
ओके हाँ.
और जैसे पोल्यूशन मैपिंग हुई तो उसमें मतलब फ्लूट तो हमेशा मतलब फ्लो हो रहा है, जैसे वो वाटर पोल्यूशन हो या एयर पोल्यूशन हो, तो सर उसको मतलब कैसे वो करते हैं मैपिंग वगैरह?
देखो दो तरफ का सैटेलाइट होता है, एक है होगा जियो स्टेशनरी और एक सन सिंक्रोनस. जो सन सिंक्रोनस सैटेलाइट है वो है अर्थ ऑब्जर्वेशन सैटेलाइट फॉर डिफरेंट इमेज क्लासिफिकेशंस, but some weather forecasting and some pollution related other sensors are there, like some weather forecasting. There's a fixed satellite is there, that is a geostationary satellite. It can be only collecting all the data of particular areas 24 into 7. And for pollution, there are different methods, like some satellite data can use this pollution data, and some IMD just uh, give some balloons or in the form of balloons and other technology. Then it give the samples, the real-time samples collected using the different sensors. So it is very accurate. So satellite-based pollution analysis is not accurate as compared to the local field-based sampling methods. Okay.
ओके सर.
Okay. Library SF raster is there. So अभी क्या है कि band 2 3 4, so these are my band in list 4 image. So just import this image, then create the layer stack, then plot RGB. So here, this is my image of different mangrove and different uh, agriculture areas. So this is a training data shape file. ट्रेनिंग डाटा पॉइंट शेप फाइल इज देयर. इसी शेप फाइल को हमको एज ए ट्रेनिंग डाटा उसको यूज करना है. देन प्लॉट पॉलीगन. सो ये है हमारा जो जो सैम्पल डाटा है जो ग्रीन कलर है. So it is showing in the green color all these samples. So it is also in the software. So these are the sample. Then we can create the supervised classification of the random forest model using the random forest model. So train data, then the class, the model is RF, then train partition is 0.7 means 70 into 30 training data. Then it classifies based on our input information. So this is the random forest classifications. So there are 6 classifications are there. So the yellow is the river, then different colors are there. So we can customize this color based on our requirement. So this can be changed into different colors, like the green color is the mangrove, then blue color is the river, and the yellow color is the agricultural land, and this red color is the settlement areas. So likewise it is classified in the random forest classification. So this image is also found, just created in the copied from these areas. So this is the classifications of the random forest of particular areas. So this is the original image, then this is the classified images. So this is some of the errors are also found. It is not clearly giving the input data. That's why it shows some of the error. Okay, so I just randomly chose this sample data. So if you are choosing consciously, then it may be the better result to this image. So likewise, you can classify unsupervised and supervised classification using the different methodologies. So I have also one classification data. Okay, so it's not there. So there are two unsupervised classification where previously seen that there's a k-mean and ISO data. This is the uh, code for the k-mean unsupervised classification. Just run this code. Think k-mean unsupervised classes 7 k. So this is the unsupervised classifications of k-mean. Then another method is the ISO data. So the unsupervised the ISO data is the code, and just execute this code. This is the unsupervised classifications of ISO data. So different classifications techniques give the different outputs, and some of the errors are also found. So it is basically very approximate result is given, like 80 to 85% correct estimations are seen in different classification technique. So in Python also you can use these classifications, or in QGIS and R and other software also available for the classification. So this is related to this. Then we'll see other things in next classes. Okay.
Okay, sir. Thank you. Okay. Thank you very much.
Okay.